Hi everyone, I'm Elvis, and in this video, I will summarize some of the most exciting and interesting top AI and LLM papers of the last couple of days. We have from Salesforce AI Research, they released Tiny Giant 1 billion parameter model. It's now the best micromodel for function calling, outperforming models 7x its size, including GPT 3.5 on cloud. So now this is a model that's specifically trained to perform function calling, and they have an entire paper about this. You can find it here. But this is exciting because I think I get questions a lot about function calling, and a lot of people are interested, especially in the enterprise space. And they are always asking for recommendation about function calling. They're interested in using it. And my typical recommendation is don't use a general purpose model for that. Try to start with something that has been trained specifically to do function calling. I think that's a good starting point. And it's usually a combination of models that support function calling will give you the best results, right? So a more like an agentic type of workflow will give you that. Very similar to the LLM routing idea, I would say, something worth exploring. But I get excited when I see companies releasing these function calling specific models because I think they're really powerful and very capable, and they're really good at that specific task. Next up, we have Mixture of a Million Experts. This is a new paper that came out and from Google DeepMind and introduces a parameter-efficient expert retrieval mechanism that leverages the product key technique for sparse retrieval from a million tiny experts. So I think the way these experts are trained and used, they can be large and they can be computationally intensive. And so what they're trying out here is to apply all these ideas, but trying to create like more tiny experts, right? Like a million of them in this case. And they attempt to decouple computational costs from parameter count by efficiently routing to a very large number of tiny experts through a learned index structure used for routing. It demonstrates superior efficiency compared to dense feed-forward networks, coarse grained mixture of experts, and product key memory layers. So there are all these mechanisms that are being used now for efficiency, and apparently they claim that their peer mechanism or peer layer that they introduce peer to these ones as well that are being used for efficiency's sake. Next up, I have this interesting paper that came out recently. It says is scaling synthetic data creation with a 1 billion personas. So why I think this paper is interesting is because there's a lot of interest in synthetic data, right? Generating synthetic data with LLMs. However, when you're generating synthetic data, what you will notice when you're doing this for a long time is that the data could be pretty generic, right? And so you may want to diversify data. You want to create maybe unique data. And so what they're proposing here is to do it in a different way, right? Rather than making it instance driven or key point driven. Most of the approaches today use either of these two, but these approaches lack the desired coverage, quality, and perspectives needed to robustly scale the data synthesis process. So let's say you were creating a conversational agent, right? And it's between a community or a social network or something like that. Somebody's interacting with that. I think the idea of having personas gives you different perspectives or gives the LLM different perspectives, and I think that's really powerful. And they show that it's effective for like math problems, but it can also be used to generate logical reasoning problems, instructions, gain NPCs, tool development, knowledge rich text, and many more use cases. I think it's an incredible idea. And this one comes from Tencent AI Lab, so do check it out. Next up, we have this paper that came out also recently on reasoning in LLMs at geometric perspective. So we know that chain of thought and all these reasoning approaches or prompting methods, they elicit reasoning in LLMs, but we don't really know too much about the inner workings and what happens behind the hood, right, with these LLMs. And so what this paper aims to do is to do it from a more mathematical perspective, and in specifically using geometrical perspective. And I've seen a couple of papers like this in the past where we want to understand the latent space, understand what word embeddings are, and these representations that are learned from these LLMs and these systems. And so I think going in that direction, while theoretic, right, you can find a lot of interesting things that can allow you to more better understand what these LLMs and how they make decisions, especially for something as important as reasoning and potentially in the future with agentic workflows like planning, for instance. So I like these papers when they come out because they do give some insight into how these models work, right? What's the connection in this case? What they mentioned is connection between the expressive power of LLMs and the density of their self-attention graphs. I think self-attention is a very powerful mechanism, very powerful technique, but we don't fully understand what it does in the context of like an LLM, right? How it interacts with other components and so on. So I think this is an interesting paper. There's a lot of these different papers that have been released recently trying to understand LLMs. I wanted to highlight this paper as well, searching for best practices in RAG. Lots of companies, lots of developers are interested in using RAG, and this one basically summarizes like chunking strategies, the embeddings to use, when to use embeddings, when to fine tune it potentially, right? What are the right embeddings to use, different vector database solutions, retrieval techniques as well, right? When to use BM25, Contriver, and embedding, hybrid search, and so on, and re-ranking and so forth, right? So how to do evaluation. So I think this is a really comprehensive report, and it basically summarizes best practices when building RAG systems. Next up is this paper, Self-Evaluation as a Defense Against Adversarial Attacks on LLMs. I did a summary of this paper. I was really fascinated by it because when we work with companies, we often get a lot of requests for how to build like verification systems or systems that can be used to defend against adversarial attacks. So when you're building an application that's based on LLMs for companies, they're very, very interested in that because obviously if anything goes wrong with that LLM or that LLM is producing sort of bad information or harmful outputs, for instance, that can affect the user, then in that case, right, becomes really a problem for that business or that brand. And so they're interested in building these defenses. And so what this paper does is it goes through evaluation of how to use self-evaluation to defend against adversarial attacks. There are a lot of experiments that they conducted, and I would highly encourage developers specifically that are building with LLMs to check out the paper because I think the evaluation suite that they're using is very close to what you would use in the production setting, which is you need to check for different settings. For instance, some attacks may be in the generator, but then some attacks may also be in the generator and evaluator if you're using some sort of evaluator as well. And this evaluator, by the way, that they talk about in this paper is backed by a large language model. So using a pre-trained language model that's untouched, you don't touch the weights on that. And so how to build something very effective, but also evaluate and evaluate continuously. So I like what they mentioned in this paper, all the discussion around it. And again, I did a YouTube video on this. Just check out my channel, you will find it. Next up is OpenAutoCoder Agentless, and they propose a simple agentless solution. So we talk a lot about agentic solutions in our channel, but here it's using a simple one without those agents to solve 27.3% of GitHub issues on the SWE bench, which is now a very popular benchmark, and specifically the light one with 0.34, so 34 cents each, outperforming all open source AI SW agents. So we have a bunch of them already, right? So we have SWE agent, AutoCode Rover. I didn't even know about this one. OpenDevin, very popular one. Aider, and now we have this Agentless. And so there's a lot of interest in that. I love the open source efforts, and obviously this one has a paper, and you can fully check out their details, and they have open sourced it as well. One avoids using the agentic workflows, and they go with a much simpler solution. So I think this is an interesting paper to also look at to see how LLMs are being used and different ways how you can build systems with LLMs without having to build complexity into it, because I think that's what's happening today, right? There's a lot of complexity that's being built in to LLM-based applications that are unnecessary. And this happens not only with agentic workflows, but it also happens with like RAG systems and even prompt engineering efforts from what I've seen. And so try to simplify things, I think is a good approach, and also it shows to be effective here as well. That's it for this video. Consider leaving a like and subscribe if you haven't. See you in the next one.